I'm very excited to introduce to you next Buzz Hayes, Managing Director of Lytro. He's going to talk about Lytro Cinema Camera, exciting things you can do with that tool, and also the exciting post-production workflows that Athera has enabled for Lytro in light field compositing. So without further ado, Buzz.
Thank you. Thanks, everybody. Again, my name is Buzz Hayes, and I'm the General Manager of Lytro Cinema. Thank you. I'd like to take a moment to thank the folks at Foundry for their support in our development of the light field software tools. It's been a very big effort that we started a little over a year ago, actually. And I also want to thank them in a big way for inviting me here today to speak on behalf of Lytro. In the next few minutes, I'm going to give you a quick overview of what light field cinematography is all about, for those of you who are not familiar with it. And then I'll talk about what we've been working on with our friends here at Foundry. So to begin, light field cinematography is a unique and transformative method of capturing motion pictures. Traditional camera technologies record light and color in a flat plane. Certain decisions must be addressed at the time of capture, as there's no way to change these key creative decisions in post-production. These critical decisions include the precise framing of the subject, the exact focused range of the shot, the amount of motion blur based on the shutter angle, and the list goes on. Light field cinematography, also known as computational cinematography, provides the ability to manipulate these decisions after the images have been captured. Imagine setting the aperture to adjust the depth of field after the scene has been photographed. The point of sharpest focus can be determined in post-production. Light field cinematography records specific information about every light ray in the field of view of the camera in 4 dimensions: X, Y, Z coordinates, as well as the angle of each ray as it emanates from its origin. Images are created from this raw light field photographic state through computation. This allows tremendous flexibility in determining the desired depth of field, the ideal location of the focus plane in the image, the precise framing of the subject, the amount of motion blur to be added to moving objects, the native stereoscopic 3D settings, even the removal of backgrounds without the need for green screen. All completely adjustable after the images have been captured. Think of light field as a full-color holographic recording of a scene. Light field cinematography allows for tremendous flexibility in crafting the visual image to best support the story with a level of control never before possible prior to the development of the Lytro Cinema camera system. As we like to say at Lytro, getting the impossible shot just became possible. The Lytro Cinema camera is the world's first professional light field capture system for motion picture and television production. The system made its debut at last year's NAB conference, and since that time, our focus has been on developing the workflow ecosystem from light field capture to light field compositing tools to the final rendered output capabilities. Traditional visual effects pipelines and workflows have been around for decades. Computers continue to get faster and tools continue to advance the state of the art in visual storytelling. However, until the advent of light field cinematography, all of the images we created were basically planar images. Even stereoscopic cinematography for 3D is the capture of 2 planar images. The perspective is captured and baked into this image pair with no ability to adjust it without resorting to laborious visual effects techniques in order to change the parallax. Light field brings a wide array of brand new creative imaging possibilities through computational cinematography for film, television, and VR. The Lytro Cinema camera is a remarkable piece of design and engineering. The system is comprised of a custom-built 755 megapixel sensor capable of capturing up to 300 frames per second with a 16-stop dynamic range. Active depth sensors capture precise depth information within the frame, which allows us to calculate extremely accurate depth data for the entire scene. The camera in its current form has a large form factor and is mounted on a custom motion control crane with a gearhead control system, offering tremendous flexibility in shot design. And finally, the integration of traditional fizz controllers and a touchscreen interface allow the control of the system in a manner very familiar to camera professionals. What makes light field cinematography truly remarkable is its ability to manipulate moving images in ways never before imagined. Focus can be adjusted within a refocusable range set by the focus puller during production. The refocusable range allows for complete control over depth of field within the frame, the precise area and amount of focus desired, even the angle of the plane of focus, all of which can be adjusted over time. Depth screen is the feature of the Lytro Cinema camera, which eliminates the need for green or blue screen on the set. The light field images captured by the Lytro camera provide very precise depth information for each light ray in the scene. In combination with the active depth sensors, a depth map is automatically generated, giving visual effects artists the ability to remove backgrounds or other elements within the frame simply and efficiently without the need for extensive matte cleanup. Motion blur is a feature in traditional cinematography that's baked into the image. The 24 frame per second cadence of the capture systems doesn't provide enough resolution to adjust the amount of motion blur in post-production. The Lytro Cinema camera captures at 300 frames per second, which allows the creation of motion blur in post-production so that it now becomes a very careful, creative decision. By capturing every light ray in the field of view of the camera, light field capture gives us tremendous flexibility in vantage point generation, giving us the ability to reposition the camera with accurate parallax changes after the take has been recorded. These subtle adjustments to the composition are invaluable in the creative process and can make all the difference between an acceptable shot and a perfect shot. By capturing millions of vantage points, we can easily output native stereoscopic versions with precise interaxial and parallax control, supporting a wide variety of screen sizes, simply and cost-effectively. Bokeh is a feature of depth of field that in traditional photography that is determined by the sensor size and the aperture setting of the camera. The effect is typically a faceted bloom based on the type of physical shutter in the camera. The Lytro Cinema camera allows for custom bokeh to be created in post-production with a wide variety of looks of traditional shutters as well as custom looks limited only by your imagination. Light field camera tracking is a feature which allows great flexibility in visual effects when compositing CG elements into live-action frames. The light field image contains extensive depth and tracking metadata that makes it very easy to create an accurate CG camera in the scene. The Lytro Cinema camera can easily track features that would be very difficult or impossible to track in traditional systems, such as shots with lighting changes or practical particle effects, which can occlude or obscure normal tracking features. We're going to take a look at a shot here that uses post-capture focus between a live-action foreground element and a visual effects background plate shot. So this is a foreground element that was composited into some live action backgrounds and some CG backgrounds. And you can notice that with the refocus control, we are able to adjust the focus from the live action into the CG and back as if it were all done in camera. Here's a little breakdown of how that shot's put together. In the shot, you'll see that the foreground action was again, photographed separately, and then later composited into a light field session in Nuke. By using the depth information recorded in the light field capture system, the rack focus works throughout the entire depth of the frame, through the CG elements and back into the live action elements, all as if they were done in camera. Variable depth of field is one of the most critical tools filmmakers use to direct the viewer's attention in the frame. By limiting focus, the viewer's eyes are directed to the area of the frame in sharpest focus. Shooting live action with limited focus range accuracy is the work of very talented focus pullers. However, with the number of factors involved in shooting with very limited depth of field, it's not unusual to have to shoot a number of takes in order to get the shot as designed. Light field capture allows very precise control over depth of field in post-production. Conventional lenses offer a great deal of flexibility in apertures down to f1. However, through computational cinematography, the Lytro system can create a lens of f.1, giving a very tight range of focus, as you can see in this image. And it gives us complete control over where the plane of focus occurs in the frame. This is virtually impossible to achieve with a conventional camera system. Depth screen is a very powerful feature of light field cinematography, as I mentioned. And by capturing the depth and location of every light ray in the frame, it's a trivial matter to eliminate elements within the frame, essentially by turning off those light rays emanating from a given distance from the camera, thus making the use of green screen obsolete. Using extremely accurate depth sensing technologies along with the light field data, it's easy to track the contours of elements in the frame automatically, and camera tracking is made more powerful than ever before. As an example, imagine shooting a scene that's perfect in every way. The lighting is just right, the actors are hitting their marks, the magic is really happening, and then suddenly there's a bump in the camera move. With light field cinematography, the camera move can be replaced with a new move in post-production, thereby eliminating the need for retakes on set due to technical problems. As I mentioned earlier, the Lytro Cinema camera captures images at 300 frames per second, which gives us the ability to perform nearly impossible visual effects techniques, such as precise motion blur and variable frame rates, easily and with a degree of control unlike any physical camera systems can provide. We capture all of the information required to reconstruct the vectors of each light ray over time. This data can be used in a variety of ways. Imagine a shutter angle of 720 degrees, or 1,000 degrees, or a completely variable shutter throughout the shot without affecting the exposure. Here's a little breakdown of how motion blur becomes a very powerful creative tool with the light field cinematography system. So here's the plate, the depth map, extraction, and now once we've calculated the vectors, we can determine the direction of the motion blur as it would occur based on the light rays themselves, and then add or subtract however much we would like to the scene for creative intent. And we can animate that over time. Now here's an example of how reframing a composition works in light field. In order to get a better framing on our background subject in this shot, we can move the camera's vantage point in the light field image. Notice the change in parallax within the frame from the string of lights to the subject-to-subject relationships. There's even a subtle change in parallax between the central background character and the wall behind her. Again, this is all determined by setting the refocusable range of the camera during capture, and then it gives you the level of flexibility you need in order to affect focus over the range of the shot, plus it gives you the ability to change the parallax. In this example, we're only changing the parallax in the horizontal dimension, but you have equal control over the vertical dimension as well for that perfect framing. Bokeh is a function of focus and depth of field in camera systems, and with the Lytro Cinema plugins for Nuke, you have complete flexibility over the look of bokeh in the image. From realistic bokeh, based on a user-selected multi-bladed shutter pattern, like this one, to a completely synthetic pattern. In this case, we're using a donut shape to create the bokeh, all of which, again, is available in Nuke. So it's really only limited by your imagination as to what you can do with bokeh in this shot. And again, this would translate through CG elements as well if you're using CG in the shot. Light field camera tracking. As you may recall from last year's presentation, there was a very extensive how-to that was shown about the making of the short film Life. And in that, there was a demonstration of how light field camera tracking works. As I mentioned before, this system offers a tremendous flexibility beyond any other camera tracking options. Feature tracking with these traditional solutions can be very difficult when there's lighting changes, or in this case, occlusions by falling debris, and imperfect camera moves, which this also has. There's a bump in the move. And by generating this light field, after we've shot this, we can then reposition the camera. We can find new tracking points because we have now vantage points around those areas that are occluded. So it gives us a lot of flexibility, not only in tracking the existing camera, but in providing new camera moves within the same scene. It should come as no surprise that the amount of data required by this system is tremendous. As an integral part of the Lytro Cinema camera system, we have a dedicated capture server, which allows us to record a whopping 300 gigabytes per second at 300 frames per second. The system includes backup servers, and the backup servers allow us to transport the data to the nearest high-speed uplink for dailies processing in Google Cloud. The servers are connected to the Lytro Cinema camera via a 100-meter fiber optic tether. which means we can have our servers offset, which is great. And the capture system is entirely scalable to meet the capacity needs of the production, which is great. And again, we're dealing with massive amounts of data, but it's all very scalable. Now, the reason we're here today is to talk a little bit about the post-production workflow for Lytro Cinema. And it's designed to utilize the cloud for dailies processing, as well as post-production manipulation and compositing of light field data. A little over a year ago, we began working with Foundry to develop a plugin suite for their industry-standard Nuke platform for both local and cloud-based workflows. And we're very excited to be here today to announce that the Athera cloud service has been designed to accommodate the Lytro light field workflow, providing tremendous flexibility, usability, and scalability of rendering resources in the cloud, enabling visual effects companies of any size to work in the light field format. Working in light field compositing on the Athera cloud enables a very seamless, fluid experience that leverages the power of cloud computing with the familiarity of the Nuke interface. We'll be releasing our Lytro Cinema toolset later this year, and I'll talk more about the Athera cloud service in a moment. LFA is a new toolset we've been developing which gives light field capabilities to CG workflows, providing all the features of light field technology in a render solution. Light field animation makes it possible to combine live-action light field imagery and computer-generated light field imagery into a light field master composite in Nuke. Imagine racking focus through a shot containing both live-action and CG elements as if the entire composite was shot in camera. Shot repositioning, relighting, and refocusing are among many of the features that will be available in the light field mastering process. And certainly, we have stereoscopic outputs tailored to each desired screen size that can be output from a single composite, providing optimal 3D viewing from everything from a small personal device all the way up to an IMAX screen. Now, speaking of light field workflow, I want to take just a moment to tell you that Lytro will be making light field test files available later this week to the ISO's MPEG Working Group 11, Subcommittee 29, and the JPEG Working Group 1 initiative regarding compression of light field. We'll be making the light field data available to the individual experts on the committees, enabling the use of the files for scientific, non-commercial purposes. The Lytro light field images will be used for the purposes of developing light field compression standards and research. In developing the Lytro Cinema tools, we understood early on that the cloud would play a very important role in managing and processing light field data. Through the power of cloud computing and the Athera cloud service, it's now possible to work with extremely large files, access thousands of render nodes, and output in a wide variety of formats in a very short period of time. Visual effects facilities can gain access to these file sets in the cloud without having to be on the same network or even in the same city, increasing productivity and certainly decreasing file I/O time. From our light field master composites, we render to any of the wide variety of distribution formats for cinema, broadcast, and streaming platforms. Athera enables this collaboration with facilities all over the world, and since it's a Nuke-based workflow, visual effects artists with Nuke experience require no extensive training to start working in the cloud. Lytro is proud to be working with the Athera team to bring light field capabilities to the visual effects industry. Here's a quick overview of the workflow using the Athera platform. The images are captured on set. Then the selected takes are sent to Google Cloud for dailies processing. The raw light field image sequences are converted into light field masters that are then used throughout the Nuke environment in the cloud. And those become the production masters. The Lytro Cinema workflow within Athera and Nuke maintains the light field properties of the composite all the way through until final renders. The Athera platform has been designed to accommodate large file sizes, our plugin set, custom scripts, essentially everything we need to use local Nuke sessions, but in the cloud. Additionally, the Athera platform provides administration controls we need in order to maintain multiple clients with multiple projects working with Lytro Cinema, much like Nathan pointed out. Here's a screenshot of the portal showing the applications we have available to us in the Athera platform for this particular project. And here's an Athera session screen capture that will show us using some of the light field plugins. We start by launching an instance of NukeX in the cloud. And again, this is all done within a conventional browser. And in this session, we're going to be opening up a light field shot. And we're going to manipulate some of the parameters within that shot. And you can see, even with the massive data set, even on a still image, we're dealing with at least a gigabyte per frame in this case. We're able to manipulate in this case, we're going to manipulate the shot focus, and we're able to play it back in the timeline in real time from the cloud. So we're opening up this light field shot in Nuke, and we're manipulating the shot's refocus using what we call our LC project tools. The light field EXR files are read into the session. In this case, the depth information and what we call our standardized light field files are used with the LC project plugin. The toolset allows us to adjust the output resolution, the refocus range, composition reframing using the U and V coordinates, exposure, bokeh, and a host of other features unique to light field. In this example, you can see the range of refocus set within the controls of the LC Project plugin, and you can see the sequence cycling in the timeline. So you can see the focus shifting from the background character in the pink shirt to the foreground, and this is done in real time in the cloud. By leveraging multiple computing resources in the cloud, the file processing times are accelerated for playback in the timeline just a few moments after processing, all within a browser on the desktop. Think of those possibilities. Lytro Cinema workflow involves very large data sets, complex algorithmic processing, and file management typically requiring a robust local network of CPUs, GPUs, and massive storage. With the Athera platform, artists can work in light field compositing from almost anywhere with the portability of a laptop, but the infrastructure of a large visual effects facility. Imagine the possibilities and the creative possibilities in working with Athera and Lytro Cinema. The impossible just became possible. Thanks very much.